Hello, my name is Evan Webb. We will be reviewing the Internet of Things and how it has helped Westrock become a leading manufacturer in the paper and packaging industry. I work for a company called Westrock. We're a global company in the paper and packaging industry. We make anything from tissue paper to folding carton to boxes. Westrock employs over 50,000 people. It was founded in 2015 through a merger of two paper companies. Since then, Westrock has acquired several other companies to make it the size it is today. All these acquisitions have been paper companies to help increase market share and also improve the vertical integration of Westrock. Our primary competitors are International Paper, Packaging Corporation of America, Georgia Pacific, Pratt, and Graphic Packaging, to name a few. I decided to focus primarily on the Internet of Things and how it has been applied at the manufacturing facility that I work at. At the facility where I work, we have two paper machines. When both machines are at full capacity, we can make a 25-foot wide sheet of paper at a rate of 1 mile a minute. That equates to roughly 2,700 tons of paper per day. We have Internet of Things applications at every step of the manufacturing process. Some key examples of the applications that we will review are dryer steam management, quality management system, distributed control systems, high process book, and Panther. Each application is used to optimize different areas of the process, resulting in improved quality of the final product, minimize energy and material costs, and improve machine uptime. Our processes in the manufacturing facility are heavily autonomous. We have two key operating systems in our facility that work congruently with each other. First is we have a programmable logic controller, or PLC. These are used to control individual parts of the process. It scans inputs and updates outputs. PLCs are able to execute programs quicker because there are not as many other processes running in the background, and it is closer to the devices that they control. Our second operating system is a distributed control system, or DCS. This ties the whole process together, not just a piece of equipment. We have sensors and transmitters installed on most machinery and equipment that are tied into the control loops and provide feedback to our control systems. Our control system takes this feedback and makes changes to our process to get back to the targeted set point automatically. These sensors throughout the process read numerous things, including raw material consistency, flows, tank levels, machine speed, temperature, pressure, vacuum, equipment position, etc. These sensors are hardwired to the program, the DCS, which improves the robustness of the system. Our operators use a distributed control system to monitor the process and make changes. This is what we control the process through. All of the feedback that we get from the process is sent through the DCS, where small changes are made to keep the process in control automatically. We also have the option to take the process out of automatic and into manual if needed to make bigger changes quicker. One of the biggest uses of the Internet of Things in our process is that we can go through a VPN system through the Internet and network into our process and make changes as needed from home. This is extremely useful when troubleshooting the system over the weekend or in the middle of the night. Additional systems are tied into our control system, or the DCS. One of the systems is provided by a third party and is called Dryer Steam Management, or DMS. This system is tied into our continuous monitoring of sheet moisture and adjusts the steam that we use to dry the paper in order to maintain the moisture target that customers request. This system allows us to optimize steam that we use in our process. Steam production consumes most of the amount of energy in the mill. Therefore, we are able to get a good rate of return on investment on anything that we can use to continuously minimize and optimize our steam usage. One of the most important applications of Internet of Things that we have is a quality management system, or QMS. It is a system from Honeywell that is tied into our DCS and controls the profile of the paper that we make. We have strict specifications for sheet moisture and sheet weight deviations across the machine, so it's important that we have a robust system tied into our control system. The QMS uses a scanner to measure the weight, which is calculated off the sheet thickness, and the moisture content across the sheet of the paper. Honeywell uses a scanner to make automated changes to our process in order to keep the quality indicators well within customer specifications. The system reduces the amount of waste in the process that would come from poor quality paper. It also leaves our customers more satisfied with the product and allows them to have less issues using our products due to minimal product deviation. We use Pi Process Book to monitor the process. This system does not have the ability to control any part of the process, but it serves as an excellent source of data. We have Pi tags that are tied into most parts of the process, and equipment provides feedback only. This data is monitored on a continuous basis through Pi and can be pulled into Excel for additional analysis. Pi has proven to be a huge asset when it comes to troubleshooting and optimizing the process. For example, if we get into runnability problems where our uptime is suffering, we can go into Pi and pull the data that we want to analyze. Pi has the ability to trend data as well. If we want to do a more detailed analysis, we can export the data from Pi to Microsoft Excel. Pi can bog down Excel easily if too much data is pulled, so it's important to filter out specific times and specific tags to minimize any chance of slowing down the analysis. Each operating system and IoT application that we have reviewed has helped make Westrock a leader in the paper and packaging industry. It has given us a competitive advantage by reducing product variance, reducing product costs, and improving machine runnability. The combination of these applications have helped make the lives of those working in the manufacturing facility much better. Continuous improvements in the IoT platform are being made, and it is important that we keep up. The integration of new technology, machine learning, and cloud computing with what we have in place is critical to maintain market share and a competitive advantage. Continuous learning and investment in big data can also help us find ways to continuously improve the process, drive down costs, and improve runnability of the machines.